Next, if y'all can give another big round of applause to John Willis, our keynote speaker today. John, how are you doing? Awesome.
Thumbs up.
Thanks.
All righty. Oh, hey, that was my surprise here.
Now he's the other side.
So I moved to Auburn, by the way. Where do you go? Ah, good. There's a couple. Because the question I was going to ask, I was born and raised in New York, but I've been in the South for a while, mostly Atlanta, and then I was surprised how I don't get as much hate for this hat, but I get way more hate for this hat. So the question is, which hat do you want me to wear? War Eagle. Yeah. War Eagle. Oh man, I was about even. I'm going War Eagle. Sorry, Alabama fans. But you guys know you're beating everybody for the last gazillion years. All right. Software supply chain, the missing links, the service mesh. I've been doing this presentation. It's really about APIs and these sort of leaky APIs and the way APIs can get you in trouble. But I've been focusing in on some of the NIST documentation, on some of the service mesh stuff. So near the end, I'll show you some examples of, let me set my timer, okay. And so who am I? So I'm probably most known because I was the co-author of the DevOps Handbook with Gene Kim, Patrick DeBar, and Jess Humble. Gene and I have done a bunch of sort of labor of love projects. I have a book. I've written like 10 books or 12 books. I lost count. But a lot of them, nobody will ever even, you can't even find them anymore. But the Beyond the Phoenix Project is pretty interesting. It's an audio-only book. And then a lot of what I talk about in this presentation and what I've been really focused on the last 5 years comes from this green reference architecture. It's a paper that a bunch of us wrote in 2019, which we started calling DevOps Automated Governance. And then we went to do a version 2 of that. And we realized it was like really boring. Unless you were really a geek, you were like, yeah. And I couldn't believe why. I thought it was going to be the most downloaded paper. IT Revolution, Gene Kim's publishing company, the Phoenix Project, a lot of books now. But I thought for sure this was going to be the most downloaded paper. Like we're showing you how to do like automated governance and compliance and risk control. And I'll talk about that. Like nobody really cared. And then so we went back to version 2, and a bank had implemented it, like fully implemented. They couldn't open source it, and we were going to tell that story again. And we realized, why don't we tell it in a Phoenix Project-like way? Like, let's make it a novel and tell the story of how, and I'll talk a little more about it. I've done more presentations. By the way, if you want that book, you can have it for free after my session, and I'll sign them. So it'll be over by the registration desk. I've also worked for a ton of companies. I was early in, I think it was a 7th or 8th person in at Chef. I sold the company to Dell. I sold the company to Docker. I worked for 3 years on an executive team at Red Hat, really focusing on this automated governance problem. And then once my time was up there, I now work for this small Norwegian company, which is interesting. They got great graphics, by the way, but I don't let them really touch my presentations too much. So I want to start off with a couple of things that are sort of real macro level, right? I know there's like a fair amount of healthcare in here and different places. So you know what? I forgot to mention this. This is pretty important for me. I have a 10-year labor of love about writing a book about Dr. Deming. If you don't know Dr. Deming, find my blog site. I talk about him all the time. I'm accused of talking about him way too much. But this summer, it's going to be the first book I've written all by myself, which I'm like there's no better feeling. I've had like 10 or 11 books, right? But when you look on Amazon and you see your book can be ordered, like it's got a special feeling. So, but in there, I talked a lot about like what the cyber world would look like. So that Deming was this industrialist that sort of changed the world. And what would he be doing if he was alive today? And so a lot of what I think about is this, starts back with Mark Andreessen, basically, you could call him the founder of the internet browsers, Netscape, but now is one of the largest VC firms, Andreessen Horowitz. And he said in 2011, which is pretty interesting if you think you go all back to 2011, software is eating the world, right? And it was spot on. It is spot on. Josh Corman, a good friend of mine, a really mentor there's two people got me into DevSecOps, which then led me to this automated governance stuff, which is Josh Corman is a white hat hacker extraordinaire. He's been on CNN. And he said in 2015, software is infecting the world. So playing on Andreessen's Like, and we know this, right? Like, I mean, just look at the dependency map of like all the open source software and the software we have. Like, look at the attacks, the SolarWinds attack, right? Like, and I mean, it is what it is. Like, we're not like, okay, get rid of all open source, right? It is like, that's what we have to deal with these things. In fact, we had an incredible conversation on ChatGPT yesterday in OpenSpace. I take this gentleman right here, like, ran it. It was awesome. And, the question is, like, we're just kind of going to have to deal with it. Yeah, there's a dark side to it. That's not this presentation. Josh actually was hired by Krebs in the beginning of the pandemic at Homeland Security CISA, and he worked on the cold chain supply chain he had to figure out the supply chain for the vaccine delivery. It was a hard problem. Like, you have to have dry ice. So you got to secure that part of the supply chain. What makes dry ice? It's petroleum. You make sure, like, he's thinking about terrorists and like what could disrupt the Operation Warp Speed, right? And so we were playing around. We were almost going to write a book together, but Josh realized it would like piss off a lot of people in the government. So we tabled it for maybe in the future. But we had this idea that software is, beyond just eating the world, it's screwing with like Maslow, right? Health, water, food, right? And so, like, this is a lot from Josh's work. Josh has testified in front of Congress. But like the pacemakers, like, there's millions go out a year, and there's a like heavy amount of them that are still hard-coded 3-character passwords, right? There's people in Birmingham that are probably running pacemakers that basically have a hard-coded 3-character that is burned in by the manufacturer. There's been like TV shows written about the diabetes pumps, right? Insulin pumps, right? Like like Dick Cheney, the vice president, and the Bush, literally the FBI and the Secret Service forced them to turn the Bluetooth off because they were just unsure. There's been horrific stories, attacks. The one that's really interesting, I have this one in my book, and I'll stop talking about my book. I got two books out right now, but one that's not in the book I'm giving away for free is the story behind the first medical device that was pulled by the FDA without proof of death. And so Josh Corman is the person. So if somebody's life is saved today, Josh Corman, and he's got an incredible story of what he had to do to get that. Because before he got the FDA to pull a device without proof of death, you had to have proof of death to basically pull that device. And then the thing that like annoys me, and I'm all in on cloud, right? But when people say radio oncology, cloud-based radio oncology systems, oh man, we won't have any problem ever again. You don't understand cloud. And the first, actually in, I think it's Mobile, was the first litigated death associated with a denial of service. So the first litigated death in the world, somewhere down the road there. And it was radio oncology. It wasn't a cloud-based, but it was radio oncology. It was shut down. A woman came in with a complex birth. They just winged it where they should have sent to a different hospital. They didn't. The baby died. So I'm going to talk about the bullet hole. So the thing I want to get across to you is a couple of points, if you care. One is, are we looking at all the things, or the obvious things might not be the right answer? And in World War II, how many people heard of the bullet hole bias? Oh, wow, almost everybody. Well, okay. All right, I'll go real quick then. For those who don't know it, Abraham Wald was a statistician during the war, and they were trying to figure out how to repair fighter planes that were coming back and put the right weight distribution, where to put the sort of metal and all that. And they realized the bias was they were looking at where the bullet holes were, and those were the planes that were coming back. What they should have been looking at where the bullet holes weren't, because those are planes that weren't coming back. So it's a good metaphor for like how we should think about security. Because if we are, and I love SBOMs, and I love all the sort of vulnerability scans, and they're necessary, but they're not sufficient. And that's point number one in this presentation. And then I'll just talk about point number 2 here real quickly, which is, if the only thing you take away from this presentation, and this one might sting a little bit, think about it. ITsec is not IT risk, or DevSecOps is not IT risk, right? Because in most organizations, particularly banks, that's where most of my experience is, you have first line, second line, and third line. If you're not communicating, so you can DevSecOps the crap out of your reference architecture and pipeline, and it could be, and I'll show you a scary looking one in a couple of minutes. But if you're not, if internal audit and the third line who is protecting the brand of the corporation, if they're not in sync with what you're doing, so you got Sneak and you got Aquasec and you got, JFrog X-Ray and you got all great products, right? Sysdig, and I can go on and on and on, right? And a couple of interesting vendors here as well. Just because you're all doing that, if you're still failing audits or you have theater-based audits, like you're not solving the problem. And that's why we're seeing these horrific breaches. This is just a slide on the growth. If we go back, I've been doing this for a really long time, but in the beginning of distributed computing, or literally starting in the mid 90s, you had these monster like Sun 10Ks, and you'd like pack them up with a billion things, and it was really sort of big servers, monolithic. The DevOps sort of thing. I was the first. I was the only American. The first DevOps days in Ghent in 2009. You started seeing pre-DevOps. You started seeing sort of distributed computing, more rack-based stuff, top of rack, and then like when we then cloud, everything went nuts. That was basically about the same time DevOps started kicking off. 2008, 2007 or 6 is when Amazon came out in the cloud, right? But all that was a swirl. 2008, 2009, the first DevOps days, 2009. So we get into this sort of, anywhere from the cloud to the right, where depending on who you're talking about, we're talking about some organization. I mean, Amazon talks, this is 5 years ago, Amazon was talking about doing like 1,000 deploys an hour, right? Like that's a super set example, but like the point is, and by the way, that's not a metric you should care about. What you care about is how quick, so I think somebody said this yesterday, right? How quick you can get a small fraction of code through the pipeline. That's what you care about. Don't fall into the trap that some company or some report or some thing tells you like you're only this because you only do 10 deploys a day. That's not the point. The point is how many deploys a day. It's Mary Poppenduk who wrote the original canonical lean software development. She said, what is the time it takes to get one line of code through your system? That's the thing you need to worry about. I didn't think I was going to spend that much time on that one. I think there's this biases. Let's see where I'm at. Yeah, I think I'm good on time. I think we run into these sort of biases. This was from the GitLab, and I'm going to talk about some technical stuff in a little bit. I think this is important stuff, right? The GitLab 2022 report, it's a good report. And in there is a couple of meta points that they made. And basically that, let's see what we got here. The first, there's sort of still there's a bias in general against security still. So if you're using GitLab and you're responding to a report, you're pretty much doing some DevOps-y stuff. And so literally 45% of the people responding to a GitLab, so that means 55% of the people who are using GitLab are saying they're not including security. That's pretty scary, actually. But here's the one that really scares me. Out of all that, 80% was saying they didn't include developers in security. So that's even where we get to the 50 mark of like, okay, we're finally getting people to include security in our delivery. This is good. A couple of presentations yesterday were clear about it, and I think that's awesome. But like, what they found is they're still not including developers. Like, so. And then I love the CrowdStrike report. This leads right into sort of my conversation now about the missing links and service mesh, is that they found 71% of all detections in 2022 what they call malware free. Right? That means they're not necessarily binaries. Right? And that's the sort of the bullet hole bias. If I listen to a lot of presentations and I see SBOM and Willis, and again, Josh Corman invented SBOMs 10 years ago. It was the executive order that sort of, because of SolarWinds, that blew it out of the water. So SBOMs are great. There's a lot of problems we're going to have to do as an industry to get this right. But the point is, if people are running around like carrying an SBOM flag, and I've got these scanners, and like if I have these products and I'm doing SBOMs, nothing to worry about. You got a lot to worry about. And that's what they're calling. So I love that they're calling it malware free. And then it goes without saying that the increase in cloud infrastructure attacks, which again, a lot of those are going to be non-binaries, are happening in the cloud. 95% increase from year. So the problem then is, if we're building complex infrastructure and we're using all the tools, which we need to be doing, I say that what we're really building is, I don't know if anybody's been to Japan and used the subway system. There's two problems with that not for me. One is, it's very complex, and none of it is in English, right? And so I'm going there in 2 weeks, but like it's kind of interesting. You do sort of figure it out, but like for my purposes of my presentation, there is something unique about it. It actually does work. But here's DJ Schleen, who built a whole documentation about reference architecture, so Sonatype. This was and DJ Schleen ran security at Aetna. He was one of the chief security guys at Sonatype, and he built this reference architecture. And that's the subway map. So there's so much there that doesn't include binaries, or does include binaries and logs from binaries or delivery that like are really hard for us to find. And so if I pierce in a little bit, I can look at like the integration, delivery, deployment, and in production. He was just using a ton of products. If the product you love is not on there, that's not the point. But I mean, if you look at like sort of GitHub, look at Fortify, you look at Aqua, Anchor, we can go, there's SonarCube down over here. We go all the way to the right. We've got Qualsys and Nessus, right? Like they're all there. And so here's the thing, right? I go to a lot of conferences, speak at a lot of conferences, and like I'll watch one vendor get up there and say, developers can go into our UI and it's so easy, and here's the DSL and here's the log structure. Next vendor gets up. Developers can go into our UI and here's the directory structure and here's the logs and here's the DSL. And like that's the conversation we're having right now about DevSecOps, which is how easy it is for any developer to go into one UI and one DSL. Unfortunately, there is no combined DSL, combined log structure, and product that I would say most people who are building a reasonably complex DevSecOps architecture, they're not combined. So we are turning our infrastructure into this subway map. And by the way, the people who are the second line, the IT risk people that I said earlier, they don't speak the same language. So not only are you giving them a UI that is written mostly for operations, sometimes developer, but not really written for auditors. What does that mean? I had somebody tell me once that, John, let me tell you something crazy. In fact, I've got it in this dialogue, basically. So I didn't even tell you. So this is a tongue-in-cheek thing I wrote about a couple of months ago. So this is the audit process, right? Sue calls Bob, the head of the sysadmin guy, and says, hey, I need for a change or pull request that happened on March 1st, 2023. I want to see the checkmarks log for that. And so Bob's like, I'm on it, Sue. And then, so Bob then calls Bill. Hey, Bill, can you get the checkmarks log for that date? And then Bill comes back and says, Tom, first off, that pipeline was written by such and such. He's not here anymore. I didn't install it. And by the way, you got me working on this customer first project, so which one do you want me to do now? And so he says, you know what, just do it, dude. So Sue calls back again and says, hey, how's it going on Tuesday? And then, so Bob asks Bill again, and Bill's like, come on, man, you didn't answer the question the first time. He's like, again, just do it. And then for whatever reason, these people didn't count the number of weeks. So they have Taco Wednesday, not Taco Tuesday. So nothing happened on Wednesday. And then Thursday, finally, Bill is like, okay, I've got it. We gave it to, he basically sends it to Sue and says, Sue, finally we got it. Here you go, Thursday, right? It was started Monday. Here's the thing. So she calls back about an hour later, so it doesn't have permission to the directory. So then now it has to go to the change manager, Jane, and they missed it Thursday, right? What did they miss? The cab, right? On Wednesday, because on the 8th day, God said there shall be cabs on Wednesday. And so they go through that. They finally, he uses fire, Bill, just use fire call, just get me to change the directory. We'll deal with the cab next Wednesday. And then, so that works. Monday comes along, Sue's like, you know what? I actually needed the Nexus log, not the checkbox log. And that's that's sort of a true story where they were like, and then they said how come they don't match? Because they do different things, right? So, I mean, if you look at the complexity that a lot of us are dealing with, if we're regulated in any format, we got PSI DSS, SOX 2, we got BST, ISO, 2701, 9001, 9000 NIST, right? And then depending on whether you're FedRAMP or MITRE, you're following the MITRE attack. And then in the STORE thing, if you haven't been paying attention, a lot of banks in the US are now starting to follow the resilience, the Digital Operations and Resilience Act built in the EU, because it's pretty solid. And then here's that green book we wrote, and it's really the purpose of that book was in 2019, a bunch of us got together and said that we're tired of organizations, particularly banks, but really any organization, spending 30 to 40 days a year on an audit. And we have incredibly low efficacy and incredibly high toil, right? And if that's not your case, you just haven't hit the scale problem yet. Because it's if you're doing one deploy a month, none of this really matters. I mean, it does matter, but if if you start getting into a scale where you've got horizontalization of all the sort of tools, you've got that presentation yesterday from the gentleman that he talked about that scale, and as you get scale, the parallelization, right? And I'm terrible at names, by the way, so I don't remember my kid's name half the time, so. So this idea then is how can we create evidence in a consistent way from that subway map or the DJ Sleen's DevSecOps reference? So we need this sort of me and this guy Bill Bensing, we were working at Red Hat trying to do this. He did the DoD, Department of Defense DevSecOps reference architecture. And so a lot of this comes from that implementation. So we've been trying to open source as much as we can of this. We do work for a vendor. So they're our sort of day job, but we created it as open source first, and then we feed it back. But this idea was an evidence vault where instead of that Sue, Bill, Bob, Jane scenario, what if all the evidence was fingerprinted and digitally signed and immutable? What if the evidence was, the actual archived evidence was sort of archived out and it wasn't, so Sue could have just gone to that change, saw the digital signatures of it, and then if needed to see the actual report, the checkmarks log, that it would actually have been archived, almost like a data warehousing. So the actual one is stored, and it's signed, so it's tamper evident, right? This is what we believe is the way. And so Bill, who I work with, has, he's got a really good article about this on IT Revolution, but he calls it governance as a service, right? Which this idea is, let's stop trying to build that subway map on top of our DevOps architecture, like the DevSecOps reference architecture, we're putting this here. So if we go, the current state for most people who haven't included security, that sort of 55% based on GitLab, that's what sort of the pipeline looks at a sort of high level, right? But then we add the DevSecOps layers, and we add all those things in between. And what we're sort of trying to drive is that you let the developers flow, and then it's sort of somewhat a GitOps model, but not specifically GitOps, but this idea that you sort of split the pipeline into the governance, and now you can collect the evidence, you can build policy around what the evidence should be, and you all meet back at the policy enforcement point, the PEP. Right, that could be the admin controller, it could be OPA code, right, OPA code, whatever. But now everybody's sort of living in existence, but now you got a really clean, separate architecture, and you're storing all the evidence in, it doesn't matter, but the way we've been implemented is something called SigStar, which is a Merkle tree implementation. So it's like a blockchain that isn't blockchain, Doesn't have all the overhead and weight of blockchain. And anyway, so this is the idea that I sort of apologize. We have a backstage plugin, we have a ServiceNow plugin, but the idea is we call these badges so that all the things that you said had to happen by the time it gets to the PEP, are they all green? And if it's red, then you can decide, well, like if it's sort of amber, maybe warning, let it go, right? And then you could have exceptions and all that stuff. But the point is that you get to the evidence. So this is an example of a SCIF, the OpenSCAP report that was run. So instead of that, Sue having to find out where this is stored, did it get rolled? Did the directory get changed? Did the permissions change? I mean, I see this quite often in large banks where they'll have tier 0 customer-facing applications like funds and stuff like that, but the pipeline that delivers the software into it is like a tier 2 or tier 3. So tier 2, like a tier 0 at a large bank, a regulated bank, highly regulated bank, they're not going to roll logs for 5 years in general. But a tier 2, it's a tier 2 every 6 months. I've seen that. So the important information that you needed no longer exists. I think the woman yesterday from Datadog, right? She talked about like making sure you save the Slack logs, right? Because those will roll, right? That was a great observation. So the whole point about the missing links that like the sort of the genesis of this presentation is, like, yes, binary is important, SBOMs are great, but there's a lot of behavior, and there's a lot of just configuration behavior. Like a missed comma could actually create an open sort of permissive definition. In fact, I'll show you the Capital One breach here. But we've had like glorious breach stories about developers putting sensitive code in S3 buckets and forgetting to clean them up for testing, unsecure API keys, hard-coded credentials, right? Not using secrets manager properly, API logic flaws, the broken object level. If you haven't seen that, right? Like you got the tree is right, but like something / patient ID is not secure, right? API sniffing. And then the thing I'm going to focus mainly on here at the end of this presentation is service mesh. Istio, that's not going to work. Things like Istio Envoy configurations. So, and I think that's the new breach theater. Yeah, we're okay. So I want to talk about a couple of breaches where there like no binaries were involved, right? Like this was a configuration breach. So this is back in 2012, it was a long time ago. But this was the second largest, called Night Capital. How many people heard Night Capital? Nobody, okay. It was the second largest high frequency trading on Wall Street, on the NASDAQ, right? And the high frequency trading, right, is sort of black box latency arbitrage, right? The transactions happen in the middle, right? And so, so what happened was the sysadmin, I can't say that they were a DevOps person because I'm not sure a DevOps person would have done this, but that's a hindsight bias, but or counterfactual. But was going to deploy an application, a new application to an 8-node cluster. Deployed it to 7 of the 8, missed the 8th one, probably a missed comma, or somewhere in there was comma, right? And so some old code got deployed. So I'll spare you sort of the joke. Basically, the old code was called PowerPeg, which was only supposed to run in test mode, which basically is an algorithm that basically buys high and sells low. It's a stress program. It got turned on in production because they reused the flag. Like, okay, sorry, that one still gets me. But they lost $440 million in 45 minutes. Their leverage was billions. They were out of business in 24 hours. A missed comma put this company out of business. Second largest high frequency trading company. There was no binary in this. This was all configuration. The Capital One breach, which is a little more recent, it's a few years ago. This one, like, I love the Sonatype people just because they love me. So I do a lot of their presentations, keynotes, and they came out new release of stuff, and I was like, their CEO Shlomi is the best CEO of any company, any in the software space. They're like, can you talk about our new release? I'm like, all right, I'm going to do him a big favor. I had a slide that says no binaries were harmed in this movie. And that's exactly true in the Capital One breach, right? So hundreds of millions of credit cards got breached, and basically it happened because this, somebody's already laughing, right? Well, what happened was a team needed an exception to go out of process. So Capital One is like the vanguard of cloud and infrastructure, and so like they do most things better than everybody else. But this team basically got an exception to go out of band. They did like, what proxy you want to use? I don't know. Who's used a proxy here? They grabbed an open source proxy. They left all the defaults on. You see that little question mark? That's bypass. Some of you might recognize what that IP address. It's the metadata server in Amazon. And like this was, if you ever follow aviation disasters, like this was the Air France 447. Like everything that could go wrong went wrong. I mean, I shouldn't be laughing, people died, but everything that could go wrong went wrong on this one. Not only was they were rolling IDSs, they basically left bypass on, and that could have stopped them if they didn't copy and paste from like Stack Overflow some VPC definitions that had permissive, and even that might not, that it would have been a pretty bad story ending at that point. But they found 145 million small business credit card applications in S3 buckets that were left there because developers didn't clean it up. That's the subway now. So this is called server-side request forgery. So again, nothing to do with binaries. No SBOM would define this. There wasn't like a CVE defined for this, right? So the thing I've been really focusing in on is here's the thing too for auditors, right? I say this to my deep security friends that NIST now has become, NIST documentation or special procedure, special publication are 0 day. And there's two things that go on. Your internal audits are reading this, and by the way, they're written by the young men and women who have written a lot of stuff for Google, and now they're out there as consultants, right? And so they're writing very complex stuff in English language that both adversaries can read and understand, and that internal auditors can read and understand. So you got them coming at you both ways, right? So in the past, if I'd interview a corporation, I'd hear things like, we don't tell auditors things they don't already know. Let's not tell them about Kubernetes till next year. Now, there's been a few years ago, right? There's been that mentality. Well, guess what? The people who wrote this stuff are now going right to NIST and documenting it. So you can't play that game anymore. You can read this English language, the one on the right, this guy works for Tetrade. He's like this brilliant young guy, Zach Baker. Like he literally, NIST brings him in now, and he wrote a whole thing about, he wrote the Zero Trust, but he also wrote one of the documentations on microservices in service mesh. And so, so the thing that the point of this presentation, I know it took a long time to get there, but I think I had to set the story up, which is, this scares me more than anything right now, right? The Istio traffic shifting. We're all turning like, oh my God. And let's be clear what's happened here. We've taken layer 3 traffic management and moved it to layer 4 and layer 7 in some cases. And so for an adversary to get to your switch config, not impossible, but very difficult. Most banks, or most large, highly secure, have a pretty mature process for changing a switch or a router, right? Now, their APIs, where the code is changing, how often are they dropping new releases and versions? They're API-based. Somebody gets into your system, they can just traverse APIs and just start plugging away and looking for. And by the way, think about a stage rollout or percentage traffic splits. So if I can get in an adversary and I can call the API to configure some YAML to call an API that basically goes ahead and says, put 10% of the traffic of this secure or highly secure traffic to this little domain name here, where I'm just doing whatever I want to do, right? And then you add in sort of polymorphic malware. I mean, so these are like, I think these are the new danger zone, right? There's already been some interesting sort of breaches around it, right? Like the canaries, it's all built into Istio, right? And this is awesome stuff, right? We don't have to write, like we don't, like, God bless all the vendors, but we may not have to pay a vendor $5 million a year to just turn it on in Istio. That's great. But what isn't great, because by the way, unless something's changed recently, Envoy is the proxy for Istio, right? And Envoy was written by Lyft, and they realized that Nginx, in their mind, this is not my words, couldn't scale east-west the way things had to be scaled. Google agreed. It became the canonical, basically, proxy for Istio. By default, last time I checked the Envoy access log, which would tell you everything that somebody did from an API call and routing and changes, is not turned on by default. So that's step one, like to make sure that's turned on. There's a great tutorial on how to sort of work with it, read it, reformat it. In fact, it's this page. So that's one. You know, and then I've been really sort of focusing on the secure controls framework, right? And compliance Forge. And I do a lot of, just because this Deming thing is in my head, I like to do Pareto analysis of everything. You know, so I basically, I took like the top 35 controls and I tried to do some Pareto analysis of what is the, I should actually, the next couple of weeks, have a report on this where I want to take, there's basically 1,000 risk controls in the SCF, right, across 275 frameworks, you know, FedRAMP, SOC 2, PSI, like all this stuff. So I want to flip that to say, this is the 20% of risk controls that are in 80% of all the frameworks, right? So I'm going to have something like that out. Because then I think we can focus on, instead of like, I know if we got to get FedRAMP, we got to get FedRAMP. We got to pass SOC 2. Like, we have to do that. But if we could focus on the top controls, and that's our first purpose, we get 80% of all the frameworks by default. And so the other thing I love about that, I think to me it's the most, of looking and fishing and waiting for somebody and all the alliances and all the reports for somebody to put something, a stake in the ground would make sense. They have this structure, you know, basically guidelines, procedures, standards, control objectives, and policy. And so what they don't have is what me and this guy Bill, mostly Bill, we're trying to do that is SCF as code. I know everybody wants to do as code, but like we're basically building a DSL. So instead of using this as just communication primitives, we were actually using this to do, and in this example I'll show you of how we're playing around. And that's all it's going to get is, it's upstream now, it's just not public yet. But like the guidelines, procedures, and standards. So like here is a traffic shaping of in Istio. Right, at 50%, right? So just an example. The better example would be like if you saw like a 1% or 10%. But like, it doesn't matter. If you wanted to make sure that there were some controls around the behavior of traffic share, which to me seems really important to keep an eye on. So this is just the YAML for Istio. And so what we did is we wrote a little Python checker. So remember that governance as code thing? So that thing where like it pipes out as governance code, there's all that process of fingerprinting. And then what we're sort of developing is the idea is we put all that in a SIG store, or a mutable data store, make it tamper evident, but we also create a manifest, a pull request manifest. So now the auditor can just run this command against this DSL, which is Python, and it will run that over again against the manifest. It won't actually do all the stuff, but the actual manifest, the JSON file, is tamper evident, meaning that like if it has been tampered with, the mesh. And then it will run this. In this case, we wrote a little DSL for, or really Python code, but to check the weight, and it had to be greater than 80%. So we don't want anybody mucking around like, you know, with some traffic in this case. And then we ran this command line, and then it just came back and said, here, you know, based on that, and then here's where the standard is. The standard is based on the SCF, that says our standard is that all traffic for this application or whatever has to be 80%. And then the guidelines would be all your information of like, where do you need to go to find out? How would you change it? Why do we have this policy? We did another example. This is interesting with the ChatGPT. I mentioned this ChatGPT. With just the playing around, we fed in our template to ChatGPT. So I think all vendors should do this. We fed in our template of what we created, this new Python sort of SCFS code. We fed it into ChatGPT, so now it sort of understood it, classified it basically. And so on the next one, we were like, hey, so this is brand new stuff, by the way. And like, on the next one, we asked ChatGPT to build us a DSL based on the classification of the language that we created, and like, except for one line, this is what it wrote for us. I mean, that's crazy, right? I mean, literally. So like, gift to vendors who haven't thought about it. If you got a reference documentation that's this thick, I'd put all that stuff into ChatGPT so that your customers don't have to fumble through, okay, page 42, okay, where's that? They literally can start asking questions about the documentation of your product. I mean, this is where we're going to go forward. I mean, this whole thing, we're going to basically build a plugin for ChatGPT. So like, this is our canonical DSL. And then we ran the report, and in this case, so I didn't tell you what the standard was. This could be more of a guideline, so you could sort of do, not a fail if you want, but like a guideline is, in this case, it had to be a very specific version of the API. So we know that that's a well-known attack vector, which is increasing the version or increasing the release number of something. Like in Docker containers, it's well documented. Somebody will just change if you've got latest and they know you've loaded it with latest, they could just put in some really high release number and that image will get run. Now, you have to have terrible hygiene to let all that happen, but it definitely happens. Anyway, so there's the making sure the version that we put in the standard or the guideline has to match. And so a couple more things, so I'm winding down. If you haven't heard about the supply chain levels for software architects, great. We sort of wrote not our own version, but we did an analysis of it. So if you go to costly.com, so SLA 4, they call it SLA, has basically 18 controls. We think there should be 51. We're just sort of extending, like if you're going to do this, by the way. And the gap between the 18 and 51 is what I've been working on with all these banks on both the DevOps Automated Reference Architecture Guide and the Investments Unlimited, what a bank actually implemented. So it's stuff that like we didn't make up. It's Nike, Microsoft, PNC, Marriott. I'm sure I'm leaving a bunch of other people out that literally put together this sort of controls reference. Okay, so we're just about done. I got 50 books. Might be about the same number in this room. Just out of courtesy to the people who pay for the books, because it's free. If you scan that code, just show me your phone. It should come back to you. And then I'll be out at the booth over there, and I'll gladly sign it if you want me to sign it. But it's a good book. It's a $20 book for free, and it tells most of the story I was told. Not all, but most of the story I just told you over the last 42 minutes and 20 seconds. Yeah, there it is again. Just give you a couple seconds. Anyway, if you want to like chat with me on stuff, that's my Deming. If there's any interest, I'm going to do a lot more on why Deming is relevant in our industry, and I've written a lot of blogs on this. My book's going to talk about it. There's a whole body of work that's been used from building toasters to nuclear power plants to cars that we seem to ignore in IT, and that's sort of been the mission I'm on right now, is to figure out why and how we can do it. So I talk a lot about that. LinkedIn is where I hang out the most. I am actually on Mastodon and Twitter, like, I don't know. Literally. It used to be I'd only go to LinkedIn like once a month. And I go to Twitter like 50 times a day. Now I go to LinkedIn 50 times a day and only go to Twitter once a month. And that's my day job, John Willis. But LinkedIn is probably the best place to get a hold of me. So thank you. I hope I wasn't too crazy on all this crazy stuff. And Oh, by the way, I live in Auburn. I said that earlier, and I'm a native now, so I'm really glad that I can drive 2 hours here to come hang out with a bunch of native Alabamans who are interested in DevOps. All right, thank you all.